Okay. So good afternoon everyone. Okay. Okay. So hi everyone. So good afternoon all. Right. Okay. Okay. So first of all, let me know whether audio and video everything clear. So if it is not clear, please give some comments in chat box. Right. Okay. Okay. So I hope everything is clear. Right. So audio and video everything is clear. I hope so. Right. Okay. Okay. So Rahul Thakur, good afternoon. Good afternoon, Rahul Thakur. Okay. So we are dealing with the subject. We are dealing with the subject electromagnetics. We are dealing with the subject electromagnetics, right? Okay. And we are dealing with magnetostatics. And we are dealing with magnetostatics, right? Okay. So in magnetostatics, we have studied about Lorentz force equation. So we have studied about Lorentz force equation and its applications, right? So next we have studied about Biot and Savart's law. So now we are studying about Biot and Savart's law and its applications, right? Okay. Okay. So we have seen how to determine with the help of Biot and Savart's law, we have seen how to determine the B field due to a current carrying wire of finite length and due to a current carrying wire of infinite length, and also we have seen how to determine the B field at the center of what? At the center of a current carrying wire of circular loop, right? Okay. And also we have seen how to determine the B field at the center of what? At the center of a square loop. So if the current is flowing around the square loop, we have seen how to determine the B field. So if the current is flowing around the circular loop, then how to determine the B field at the center. And if you are having a semicircular loop, then how to determine the B field. So if you are having only a quarter part of the circle, okay, so let us say here the current is flowing like this, right? Here let us say the current is flowing like this. So we have determined, we have seen how to determine the B field at this center. So let us say we have considered the radius as rho, right? Okay. So all these things we have seen, and also we have determined the B field due to a current carrying wire of finite length, and also we have determined B field due to a current carrying wire of infinite length, right? Okay. So all these things we have determined here, and also we have determined the B field at the center of what? At the center of a hexagon, right? So at the center of a hexagon, and also we have determined B field at the center of what? At the center of an, or at the centroid of an equilateral triangle. So this is equilateral triangle, right? Okay. So all these different types of problems we have solved based on what? Based on Biot and Savart's law. Right? Okay. 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 So today we'll try to solve one more problem here, right? Okay. And also we have seen in the yesterday's class here, we have seen one problem, that is I have given the wire like this. So I have bent the wire in this manner. Okay. So what is the current flowing through this wire is I, right? So for this problem also we try to determine the B field at some point P1, right? Okay. And we have taken the same wire and bent this into semicircular loop, So then we have determined, for this case we have determined the B field at the point P2. Okay. So then we have taken the ratio of what? B field at point 1 to B field at point 2. Okay, so this problem also we have solved here. So we have solved different types of problems based on what? Based on Bayet and Savart's law. So for all this, the base is nothing but what? The base is nothing but Bayet and Savart's law, right? And also we have seen that along the wire here, along the wire. So if you consider any point along the wire, so along the wire, the B field is what? The B field is 0. Understood? Okay. So why it is 0 and all those things we have already studied, right? Okay. Okay. Yeah. So now we try to solve one more problem here based on this Bayet and Savart's law. So once we complete that, then we will start Ampere's law, right? Okay. Okay. Yeah. So one problem we are going to solve here, one more problem. Okay. So I am considering a circular loop and here let us consider this as z axis and this as x axis and this as y axis, right? Okay, so let us consider this as x axis, y axis and z axis, right? Okay. Okay. Okay, so this is z axis here, this is z axis, this is x axis and this is y axis. So this is the circular loop, this is the circular loop, right? Okay, so this is the circular loop. So let us assume the current that is flowing through this circular loop is I. So the current is flowing through this circular loop is I, right? Okay, so this circular loop is placed, it is placed where here? It is placed in xy plane. So this circular loop, is placed in z is equal to 0 plane, z is equal to 0 plane. So that means xy plane. Okay, and its center here, its center is at origin. So this center is at origin, right? Okay. Okay. So or I will simply represent this with O here. This origin I am representing with O. Okay. Right. Now we have seen already how to determine the B field at the center of what? At the center of this circular loop. Yes or no? We have already derived the expression for what? Expression for B field at the center of the circular loop. Now here we try to determine the B field. Now here we try to determine the B field. We try to determine the B field at some point 0, 0, z. So at this point, let us say some 0, 0, z, we try to determine the B field here. We try to determine the B field. Okay. So at some point 0, 0, z, we try to determine the B field. That means along the axis of this circular loop, at some point 0, 0, z, we try to determine what? We try to determine the B field. Okay. So then at the same point below the circular loop at 0, 0, minus z also we try to determine the B field, and we will see what is the difference between the B field at this point and at this point. So all these things we are going to analyze here. Right? Okay. Okay. Yeah. So just follow Bayet and Savart's law. Just apply Bayet and Savart's law. Understood? Okay. So here okay. So here what I am doing here is I am considering. So if you want to apply Bayet and Savart's law, you have to consider what? First of all, you have to consider a small differential current element. So we try to determine the small differential B field due to this small differential current element. So once we determine that, then if you want the total B field due to this total current carrying loop, okay, then you have to integrate throughout this circular loop in order to get what? In order to get the total B field. Understood? Okay. Okay. So here, see here, so I am considering a small differential current element, a small differential current element. So this is small differential current element, I am calling it as IDL bar. So this is nothing but IDL bar, right? Okay, so the radius here, the radius, I am considering the radius of this circular loop as what? As rho. The radius of this circular loop is rho. Okay, or I will, okay, so I will consider the radius of this circular loop is rho, right? Okay, now I want to determine, I will try to determine the small differential B field at this location due to this small differential current element. Okay, so okay, so the distance from the vector that is pointing from the small differential current element to the point where you are trying to determine the B field is nothing but what? Is nothing but what here? Is nothing but R bar. Yes or no? So this is nothing but R bar, right? Okay, okay, yeah. So the distance from the small differential current element to the point where you are trying to determine the B field is nothing but R bar, okay, okay, yeah. So now what is the small differential B field at this point here due to this small differential current element? So first write down that expression, what you are going to get, tell me what you are going to get. So apply just Bayet and Savart's law. Okay, so dB is equal to what? The small differential B field is equal to what? Is equal to mu into I dl bar cross what? Cross AR cap divided by what? Divided by 4 pi R square, divided by 4 pi R square, right? Okay. Okay, so see here, so what you are going to get here, dB bar is equal to what? Is equal to mu into I. So what is this small differential length along this circle here, along this circle? So you have to consider this small differential length dl bar is nothing but what? Is nothing but small differential arc length, small differential arc length. So what is the arc length along this circle here at this location? What is the arc length? We have seen many times, yes or no? What is the arc length? This dl bar is nothing but what? I can write it as rho into d phi a phi cap, rho into d phi a phi cap. So I have explained this many times here. Okay, so how to consider this differential arc length and all those things, right? Okay, so this dl bar, this differential length is nothing but this differential arc length, that is nothing but what? Rho d phi a phi cap, rho d phi a phi cap, right? Okay, so here I am writing this dl bar as what? Rho d phi a phi cap, d phi a phi cap cross AR cap. AR cap is the unit vector along what? Along R bar. AR cap is the unit vector along R bar. Okay, so what is this unit vector here? How to represent unit vector? So AR cap is equal to what? Is equal to R bar divided by what? Divided by magnitude of R bar. So how to represent this unit vector? Tell me how you can represent this unit vector. So what is R bar here? What is R bar? So let us consider this point here. Let us consider this point. Okay, so at this point, so this point is lying along y-axis, so I am representing this as 0 comma rho comma 0. Okay, so the distance from here to here is rho, so I am representing this point as 0 comma rho comma 0, and this point is nothing but what? This point is nothing but 0 comma z. Okay, so R bar is the vector that is pointing from 0 comma rho comma 0 to what? To 0 comma z. So what is R bar? Write down here, write down this vector that is pointing from this point to this point. Tell me what you are going to get. So 0 minus 0 will be 0, 0 minus rho. So 0 minus rho, that is minus rho Okay, so minus rho okay. So what you are going to get here, tell me. Wait. So this r bar is equal to 0 minus 0 will be 0, then here this component rho minus 0, right, sorry, 0 minus rho, so minus rho, right. So this is nothing but, wait here, so this is nothing but minus rho a rho cap. Next 0 z minus 0 is nothing but what, z minus 0 is nothing but z az cap. So divided by what, divided by magnitude of r bar, so that is nothing but square root of what, square root of rho square plus what, rho square plus z square, rho square plus z square, right. Okay, yeah. So in this manner I can write the unit vector ar cap. So ar cap is equal to what here, ar cap is equal to minus rho a rho cap plus what, plus z az cap, right. Okay, yeah. Okay, so now see here, mu I rho d phi a phi cap cross ar cap is nothing but minus rho a rho cap plus what, plus z az cap, divided by what, divided by square root of what, square root of rho square plus z square. So here divided by 4 pi r square. So 4 pi r square means what here, r square means magnitude of r is square root of rho square plus z square, r square means what, r square means rho square plus what, rho square plus z square. Okay, yeah. So this is nothing but ar cap, so this is nothing but ar cap. Okay, see, if you want to understand how to write this ar cap, I will tell you here in another manner. See here you are having r bar, right. So this r bar can be resolved into what, can be resolved into two components. One is what, one is along what, one is along z direction, yes or no. See, the r bar is like this, r bar is like this, right. Okay, so I can resolve this into two components. One is what, one is along z, one is along z direction, and another one is along what, another one is along minus arrow cap direction, along minus arrow cap direction. Understood? So this is nothing but what, this is nothing but the distance from here to here, the distance from here to here is nothing but what, is nothing but rho, and it is pointing radially inward, so I can write it as rho into minus arrow cap, and this vector is pointing in downward direction, and the distance from here to here is z, so I can write this as what, z into what, z into sorry here, so here z is not pointing downward here, z has to point upward direction, right. Okay, see here, wait here. So this r bar can be resolved into two components. One is along minus arrow cap, and another one is along what, another one will be along what, will be along plus z direction, So this component is nothing but z az cap, and this component is nothing but rho minus arrow cap. So that means r bar is equal to what, r bar is equal to, I can write it as what, minus rho arrow cap plus what, plus z az cap. Understood? So from here also you can determine what, you can determine ar cap, that is equal to what, r bar divided by magnitude of r bar. So I can resolve this vector into two components. One is along what, one is along z direction, and another one is along what, another one is along rho direction. One thing remember here, as you move from this point to this point here, as you move from this point to this point, what happens to this side, what happens to this component here? So this component is going to move like this, and this component is going to increase like this. Yes or no? As you move from this point to this point, its projection, the projection of r bar along rho is going to point in this direction, and the projection of this r bar, along z is going to increase in this direction. Yes or no? Okay, yeah. Right. That's what I am saying here. This is how you have to determine. Parasmoon. This is radial direction, na? This is radial direction, yes or no? This is radial direction or not? So that's why I am considering radial direction is nothing but what? Aero caps. Now it is pointing towards the center, So that's why I am considering it as minus aero cap, right? Understood or not? Parasmoon. See here. See, this is R bar I am having. This is R bar I am having, right? Okay. So this is the center of the circle. This is the center of the circle, and so this point is, sorry, wait. Let us say this is R bar. This point is what? 0, 0, Z, right? Okay. So this point is 0, 0, 0. Okay. Okay. So now see here. Now I can resolve this vector here. I can resolve this vector into two components. One is what? One is along Z direction. Yes or no? One is along Z direction, right? So this is nothing but Z component of R bar. And another one is along what? Another one is along radially inward direction. Understood? So here I can write this as what? This is rho, and it is pointing towards the center. That means it is pointing in minus aero cap direction, and this component is pointing in positive Z direction. So I am writing this as what? I am writing this as Z AZ cap, right? Okay. So now R bar is having two components here. One is along minus aero cap direction, and another one is along what? Another one is along Z direction, positive Z direction. Okay, is this clear? Tell me here, Parasmoon and Rahul Thakur, tell me, is this point clear? How I have written this R bar and how I have written this AR cap, is this points clear? Tell me here, Rahul Thakur and Parasmoon. Yes? Okay, so I hope it is clear here. I hope it is clear, right? Yes or no here? Clear? Okay, fine. Okay, so here I have whenever I am writing here AR cap, I have directly used cylindrical coordinate systems, so that's why you may have not understood here. So that's why again I have explained how you can resolve this into two components, and this component will become rho minus aero cap, and this component will become Z AZ cap. Okay, now I hope you have understood this one, right? Okay, okay. So now see here. Okay, so this is the B field we got. This is the B field we got. This is the small differential B field, right? So this is equal to what here? This is equal to mu I rho d phi, mu I rho d phi divided by 4 pi. Here rho square plus z square. Here square root of rho square plus z square is nothing but what? Rho square plus z square whole to the power of what? Whole to the power of 3 by 2. Okay, next A phi cap cross aero cap here. What is A phi cap cross aero cap here? What is A phi cap cross aero cap? So aero cap, A phi cap and AZ cap, right? So now what is A phi cap cross aero cap is nothing but minus AZ cap, and already you are having here minus. So minus of minus will become plus. Yes or no? So you are going to get here rho into what? Rho into AZ cap, rho into AZ cap. Next, A phi cap cross AZ cap here. A phi cap cross AZ cap is nothing but what? Is nothing but aero cap. So that means here you are going to get plus Z into what? Plus Z into aero cap. Plus Z into aero cap. Right? Okay. So that means here I can write this one as mu I. See here, mu I, okay, rho into rho will become what? Rho square d phi divided by 4 pi into rho square plus z square whole to the power of what? Whole to the power of 3 by 2 az cap plus. So if you multiply this term with this one, what you are going to get? Mu I rho z d phi divided by what? Divided by 4 pi into what? Into rho square plus z square whole to the power of what? Whole to the power of 3 by 2. This is aero cap. This is aero cap. So that means this small differential B field here, this small differential B field at point 0 comma 0 comma z is having which components here? Is having a z component. Yes or no? It is having z component. So this is dBz. Okay, so it is having z component, and it is having what? It is having rho component. So I am writing this as dB rho aero cap. Understood? So this small differential B field at 0 comma 0 comma z is having what? Is having z component, as well as it is having what? It is having rho component. It is having rho component, right? Okay. Okay, yeah. So that means see here. Where here? Okay. So I will copy this figure here. Okay, so that means so that means here the small differential B field at this point, the small differential B field is having two components. It is having two components. One is what? One is along rho direction. Rho direction means what here? Radial direction. Understood? So one is along radial direction and another one is along what? Z direction. So that means the small differential B field at this point is having a component along what? Along radial direction, that means along rho direction. So that is a dB rho aero cap. So aero cap means it has to point away from what? Away from center. Okay, that's why I have written in this manner. Next, it is having another component, that is nothing but what? dBz az cap. So that means it is having another component along what? Along z direction. Along z direction. Right? Okay. Okay, along z direction. Okay. It is having another component along z direction, right? So this component is dBz az cap. So that means the resultant B field here, the resultant B field at this point, the small differential B field at this point is pointing in this direction. Yes or no? So this is nothing but dB. Right? So the small differential B field at this point 0 comma 0 comma z, due to this small differential current element is having two components. One is along what? One is along rho direction and another one is along what? Z direction. That means the resultant B field, the resultant small differential B field is going to point in this direction due to this small differential current element. Right? Okay. Now see here. Now exactly opposite to this one here, exactly opposite to this one, I can have what? I can have a small differential, I can consider a small differential current element. I can have a small differential current element. Right? Okay. So here this I am representing it as IDL bar. So if I do the same analysis here, so due to this one also, the small differential B field at this location is going to have what? Is going to have two components. One is along what? One will be along dB rho aero cap, dB rho aero cap, and another one will be along what? Another one will be along dBz az cap. Another one will be along dBz az cap. Understood? Okay, so the resultant B field at this point due to this current element will point in which direction here? It is going to point in this direction, due to this small differential current element. Okay, so now what you can observe here? See, whatever the small differential current element that is present here, the same small differential current element you can have exactly opposite to this one. So due to this one also, if you do the same analysis, whatever the analysis we have done, in the same manner, if you try to determine the B field due to this small differential current element on this side, okay, so you are going to get the B field two components here, two components of the field. So the one is along what? One is along rho direction and another one is along what? Z direction. Understood? Now similarly you can consider a small differential current element at this location. Now exactly opposite to this one, you can consider another small differential current element exactly opposite to this one. So due to these two current elements also, what will happen here? So it is going to have two components. One is along rho direction, another one is along what? Z direction. Okay, so what you can observe here, which components will get cancelled and which components will get added up here? So because of this symmetry in the small differential current elements, which components will get cancelled and which components will get added up? Tell me. Which components will get cancelled and which components will get added up? Tell me here. Tell me. So in the same manner here, whatever the small differential current element you can consider, so that small differential current element is going to have what? Is going to have a rho component as well as what? Z component. Understood? Okay. So for each and every small differential current element, there exists what? There exists a symmetric current element on the other side. So because of this symmetry, which components will get cancelled and which components will get added up? Tell me here. Tell me. No, you should not say y here. You should not say y. We are using what? We are using cylindrical coordinate system. So that is rho, phi and z. So which components we got? Small differential field is having which components? Rho component and z component. Right? So this is nothing but what? This is nothing but rho component. Yes or no? If I consider the small differential current element here at this location, then B field at this point can be resolved into two components. One is what? One is along rho direction and another one is along what? Z direction. So like that, for each and every component, for each and every small differential current element, you are going to have what? You are going to have two components of B field. One is along Z direction, another one is along what? Another one is along aero cap direction, that is radial direction. Right? Okay. Okay, yeah. Right? Parasmoon, understood? See, if I consider somewhere here in space, okay, it is going to have the components like this. It is going to B field, if B field is like this here, so then it is going to have what? It is going to have rho component as well as what? Z component. See, rho component is nothing but what? Rho component is always parallel to what? Is always parallel to this XY plane. Yes or no? Okay, so the components that are parallel to XY plane will get cancelled and the components that are perpendicular to XY plane will get added up. But here the component that is parallel to XY plane is nothing but what? Is nothing but aero cap. Is nothing but aero cap. Yes or no here? Understood? Yes? Okay. Rahul Thakur, is it clear? Tell me here. So if the B field is like this here, if the B field is like this, okay, so then you can resolve this into two components. One is what? One is perpendicular to this xy plane, and another one is what? Parallel to xy plane. So the component that is parallel to xy plane is nothing but what? Radial component, that is along rho direction. Understood? Okay, so like that, for each and every current element you can have two components of the B field. One is what? One is along rho direction, and another one is along what? Another one is along z direction. Rho direction means that is parallel to what? That is parallel to xy plane, right? Yes or no here? Rahul Thakur, is this point clear? Tell me here. Okay, so that means, see here, so that means here I have considered a small differential current element. Due to this one, I got two components. One is rho component, another one is what? Z component. If I consider a symmetric current element on the other side, then also you are going to get a rho component and Z component. So this rho components will get cancelled and Z components will get added up. Yes or no? So that means I don't need this rho components here. I don't need this rho components. Why here? Because anyway, because of the symmetry, it is going to get what? It is going to get cancelled. So I don't need this rho component. Okay. Finally, the resultant direction will be along which direction? It is going to have only Z component. It is going to have only Z component. Right? Okay. Okay. So so the small differential B field, is going to have only Z component. So that is dB is equal to dBz here. It is going to have only Z component. dBz is equal to what here? What is the Z component expression we got? So that is mu I rho square d phi divided by what? 4 pi rho square plus Z square whole to the power of 3 by 2. Right? Okay. So mu I rho square by 4 pi into rho square plus Z square whole to the power of what? Whole to the power of 3 by 2. Whole to the power of 3 by 2 into d phi. Right? Okay. So into d phi az cap. So this is the only component that will be left out. All the rho components will get cancelled. Right? Okay. So Sai Vinay Kumar. Yes. Okay. Okay. So this is the small differential B field, right? Okay. So now if you want the total B field here, if you want the total B field due to the total circular current carrying loop, okay, then what you have to do? You have to integrate on both sides. So if you integrate on both sides, you are going to get the total B field. So that is equal to integral mu I rho square divided by what? Divided by 4 pi into rho square plus Z square whole to the power of 3 by 2 d phi az cap. Now here phi must vary from where to where here? You have to consider the total current, the total circular loop here. You have to consider the total circular loop. That means phi must vary from where to where? Phi must vary from 0 to 2 pi. Yes or no? So here phi must vary from 0 to what? 0 to 2 pi. 0 to 2 pi. Right? Okay. So if you do this integration here, so take all the constants outside the integration. Take all the constants outside the integration. Mu is constant, I is constant, rho is constant, 4 pi is constant, rho is constant, Z is also constant. Yes or no? So take all the constants outside here. So you are going to get mu I rho square divided by what? Divided by 4 pi into rho square plus Z square whole to the power of 3 by 2. Whole to the power of 3 by 2 integral phi equal to 0 to 2 pi d phi. See how simple integration is. Just you have to know how to write the expression for the small differential B field due to a small differential current element. So if you know that one, okay, then because of the symmetry, which components will get cancelled and which components will get added up. Okay, so that's what you have to analyze. So once you came to know that only Z component of the field will exist, then take only Z component of the field, and in order to get the total field due to the total circular loop, you have to integrate throughout the circular loop. So while integrating, what you have to do? You have to substitute phi equal to what? Phi equal to 0 to 2 pi, because you have to consider the total circular loop. right? Okay, so now if you do this integration, it is very simple here, yes or no? So mu I rho square divided by what? Divided by 4 pi into rho square plus z square whole to the power of what? Whole to the power of 3 by 2. This integration, integral d phi is phi. If you substitute the range, what you are going to get? You are going to get 2 pi. Okay, so here 2 pi 1s and here 2 pi 2s, right? So therefore B field here, therefore B field is equal to what? Is equal to mu I rho square. So this is at what point here? At 0 comma 0 comma z. B field is equal to mu I rho square divided by what? Divided by 2 into rho square plus z square whole to the power of 3 by 2, whole to the power of 3 by 2. So the direction is along which direction here? The direction is along AZ cap direction, AZ cap direction. Yes or no? Yes or no here? Okay, so is this clear? Tell me. So this is the expression for B field. This is the expression for B field along the axis of the circular loop, along the axis of the circular loop at some point 0 comma 0 comma z. Okay, mu I rho square by 2 into rho square plus z square whole to the power of 3 by 2. And we know the result. We know the result for the B field at the center of what? At the center of circular loop. So what is the B field you are going to get? Tell me. At the center of the circular loop. We have already know the result here. So from here also we can get the same result. So what you have to do at the center of the circular loop means what? Means z is equal to what? You have to put z equal to 0. So if you put z equal to 0, you are going to have what? Rho square whole to the power of 3 by 2. That is, you are going to get rho cube in the denominator and rho square is present in the numerator. Rho square will get cancelled, and what is left out in the denominator? Only rho. Okay, so that means you are going to get at the center here, at the center, what you are going to get? B field is equal to mu I by what? Mu I by 2 rho AZ cap. Mu I by 2 rho AZ cap. Understood? So the same expression we got or not? Yes or no? Okay, at the center of the circular loop. Okay? Okay, yeah. Okay. So is this derivation clear here? If you are having any doubts, please ask me here. Parasmoon, Rahul Thakur, Sai Vinay Kumar. Tell me here. If you are having any doubts, please tell me. Is this clear? Okay. Okay, yeah. Okay. So now tell me, what is the expression you are going to get? What is the expression you are going to get at 0 comma 0 comma minus z here? You are going to get the same expression or different expression? So at 0 comma 0 comma minus z, what you are going to get? The same expression. Phi is always taken from 0 to pi. Yes, phi is taken from 0 to pi because you are moving in anti-clockwise direction, na? Right? Phi always consider from 0 to 2 pi r. Starting is 0 and final is what? Final is 2 pi. Right? So if you are moving in anti-clockwise direction, then this a phi cap will be positive. If you are moving in clockwise direction, you have to consider a phi cap as what? Negative. Understood? Okay. See, here we are considering what? Here we are considering the total circular loop or not. We want to determine the B field due to the total circular loop. Since we are considering the total circular loop, we have to consider phi as what? Phi as 0 to 2 pi. Parasmoon, what you are asking here? Phi is always taken from 0 to pi. What 0 to pi here? 0 to 2 pi na. Here we are considering the total circular loop here. Here we are considering the total circular loop. Yes or no? So if you want to consider the total circular loop, then phi must vary from where to where? From 0 to 2 pi. Right? Okay. Okay. So Rahul Thakur, are you there? Rahul Thakur, are you there? I am not getting any response from your side. Rahul Thakur, are you there? Okay. So now tell me, what is the B field that you are going to get at 0, 0, minus z? Will it be the same expression or different expression? Tell me first. Will it be the same expression or different expression? Tell me here. Paras Moon. At 0, 0, z we have determined the B field, right? Okay. Now what is the B field at 0, 0, minus z? Will it be same or different? That's what I am asking. Tell me. Paras Moon, Sai, Vinay Kumar, Rahul Thakur. Tell me here. At 0, 0, minus z, B field will be same. That means the same expression you will get or different expression. That's what I am asking. Right? Tell me here. Expression will be same. Okay. So here this point is at 0, 0, z and this point is at 0, 0, minus z. So the distance from here to here and the distance from the current element to this point, each and everything will be same. Okay. And hence here also the B field is going to be what? B field is going to be same. Now tell me the direction of B field at this point, the direction of B field at 0, 0, z here. The direction of B field at 0, 0, z we got in which direction? We got in AZ cap direction. We got in AZ cap direction. Now what is the direction of B field? What is the direction of B field at 0, 0, minus z? Tell me. The expression will be same here. The expression will be same. Here I am asking about the direction. Here I am asking about the direction. At 0, 0, z we got the direction of B field. The direction of B field is pointing in AZ cap direction, that is in upward direction. Yes or no? At this point the resultant B field is pointing in positive Z direction. Yes or no? Now what is the direction of B field at 0, 0, minus z? What is the direction of B field at 0, 0, minus z? Tell me. What is the direction of B field at 0, 0, minus z? Minus AZ cap direction. How here? How minus AZ cap direction? See, we have studied about circular ring, yes or no? Uniformly charged circular ring. So there, if the charge is distributed uniformly around the circular ring, then we have seen that above this wire, above this charged ring, the electric field is going to be in positive Z direction. Below this charged ring, we have seen that the electric field is going to be in negative Z direction. But here the B field, whether you consider at 0, 0, z or 0, 0, minus z, the resultant B field direction will be along which direction? Will be along positive Z direction only. Why here? Why? See here, the current. See here, the current is flowing in which direction? The current is flowing in anti-clockwise direction. So use right hand rule here, use right hand rule. So enclose the four fingers along the current direction in anti-clockwise direction. Okay, so then what is the direction of B field? The direction of B field is pointing in which direction? Positive Z direction, positive Z direction. So it depends upon whether the current is flowing in anti-clockwise direction or clockwise direction. If the current is flowing in clockwise direction, then only B field is going to point in negative Z direction. right? Okay, so this is where generally the students will get confusion when comparing to electric field here. So there they have told that above the uniformly charged ring, the electric field is pointing in positive z direction. Below the uniformly charged ring, the electric field is pointing in negative z direction. But here it is not the case. It depends upon what? It depends upon how the current is flowing. Okay, so here the current is circulating in anti-clockwise direction. So that means B field, whatever the point you can take here, whatever the point you can take on this axis, at each and every point the B field must point in which direction? The B field is going to point in positive z direction. Whether the point may be above this circular loop or the point may be below the circular loop, it doesn't matter. Okay, why here? Because the direction of B field will depends upon what? Depends upon how the current is circulating around this loop. Okay, so if it is circulating around this loop in anti-clockwise direction, then whatever may be the point you can consider along this axis, the B field must be what? The B field must be in which direction? The B field must be in positive z direction. If I change the direction of current, okay, so then only, that means if I consider the current in clockwise direction, then only the B field is going to be in which direction? Is going to be in negative z direction. So if you want, you can do the same analysis here. You can do the same analysis and try to determine the exact expression with direction at point 0, 0, minus z. You are going to get what? You are going to get only positive z component of the field, right? Okay, okay, yeah. Whether the point is here or here, it doesn't matter, because it depends only upon how the current is circulating around the wire, right? Okay. So whether you go to this point, the current is circulating in anti-clockwise direction. Whether you go to this point, still the current is flowing in anti-clockwise direction, and hence the direction of B field will always point in which direction? Positive z direction, right? Understood, Parasmoon? Understood? Is this point clear? Tell me here. Is this point clear? Yes? Tell me, Parasmoon, is this point clear? Tell me here. If you give some response, then only I will know whether you are able to follow the lecture or not. Okay. So if you are having any doubts, you can ask me. Otherwise, please let me know, is it clear or not? Yes? Tell me here. You can do it mathematically here, that is no problem. Okay, so there is no problem, you can do it mathematically. But here, how you have to analyze the direction, that's what I am saying. See, whether you are at 0, 0, z or 0, 0, minus z, if you move from this point to this point, the current is not changing direction, right? It is still flowing in which direction? Anti-clockwise direction, right? Okay, so that means whatever the point you can take, the B field must point in which direction? Positive z direction only. Okay, so B field direction will depend upon what? Will depend upon how the current is circulating here, right? Okay, so that's what I am saying. Okay, so if you want, you can go and you can do all the analysis and everything, so you are going to get the same result. Okay. Varish Kumar, good evening Kumar. Okay. Okay, yeah. So next topic is Ampere's law. Next topic is Ampere's law. So next topic is Ampere's law, right? Okay. Okay. So with this we have completed Biot and Sauer's law. So next we will start Ampere's law here. Next topic we will start Ampere's law. Okay. So but not today here, but not today. Okay. Okay. So today I am winding up the session here with this. Okay. So tomorrow I will start this Ampere's law here. Tomorrow I will start with this Ampere's law. Okay. So today I am winding up the session. So tomorrow we will meet exactly at 4 p.m. Tomorrow we will meet exactly at 4 p.m. Right? Okay. So we will start tomorrow Ampere's law here. Tomorrow we will start Ampere's law. So with that problem we have completed Biot and Sauer's law. Okay. So if you are having any doubts, you please work out on those Biot and Sauer's law. So based on my previous lectures, you can go through that and you can practice all those things, right? Okay. So once you get familiar with all those things, then we can start from tomorrow onwards. We will start Ampere's law, right? Okay. Okay. So we will meet tomorrow exactly at 4 p.m. So until then, take care. Bye bye.